So hey there everyone. Today we are going to discuss this problem, that is make n 0 from today's CodeChef Starters 113. So first of all, let's have a look at the problem statement. So you are given a positive integer n. In one operation you can either subtract 3 or subtract 4 from n. So can you make this n 0 by performing any number of operations? Okay, and the input is test cases and all of those things. And okay, you have to just return yes or no in the case when you are able to make n 0 after doing n number of operations. And if there is no such case possible, then in that case you have to return no. So I guess the problem statement is very simple. I don't have to simplify it more. So basically you are given with one number n, and starting from this number n, you have two choices. Either you can subtract 3 from this, or either you can subtract 4 from this. So by making these two choices, you will end up in certain state. So if that state of n is becoming 0 at any case, like there will be many states over here, there will be many such branches, or I can say tree will be formed over here. So at any point, if you are getting this as 0, this state of n as 0, then in that case you will be returning with yes. And if we are not able to find any such path over the span of this whole n, then you will be returning with no. So that is what they are trying to ask you. Now if you just try to look over here, is let me explain you using one example. Let's say I'm taking example of n as 7, right? Now not 7, let's take it a little bit bigger number, let's say 17. Okay, so now whenever you are starting with any arbitrary number, like in this case when you are starting with 17, how you will know? Here you have two choices. You know this, that you can subtract 3 from this, that is you can do 17 minus 3, or else you can do 17 minus 4. But now my question to you is, how you will be going to make this choice, that either at a single point, you can either do minus 3 or you can either do minus 4. You can't do both of these operations simultaneously. That is obvious, right? So now how we will make judgment that at any particular point or at any particular state of n, you will be doing minus 3 or minus 4. How you will make this judgment? That is my first question to you. So let me give you answer to this. So now here you can see that obviously there is no such concrete thing through which you can see that by doing minus 4 over here at the end you will be getting 0. There is no such indication over here at this point of time, right? And at this point of time also you do not know that even after doing minus 3 you will end up in some position where your n will become 0. You don't know. So what you will do simply is, you will try each and every case. Like for 17 minus 3, this will become some number. Let's say this number is n1. Consider it as n1. Consider this number after 17 minus 4 as n2. Now what you will do, you will again do minus 3 over here. Again you will make two cases, because there are two possibilities. Either you can subtract minus 3 or either you can subtract 4 from it. So again two possibilities for this number n1. Again you will explore both the possibilities for this number n2. Okay, this number n2, and you will check through all the possibilities that if I'm able to get this n as 0 or not. So basically, since you are not able to make a judgment at any of this step, what you will simply do is you will explore all such possible paths using subtraction of 3 and 4 on each and every path, and you will check if you are getting 0 or not. Correct? So I hope that you have got this answer, that how you are going to make a judgment. The answer to is that you are not going to make any judgment right now at any step. So since you can't make the judgment, you will explore all the possible paths, and from there you will be able to know that if your n can be 0 or not. Correct? So let's have a look at this example only. Let me show you some observation from this example only. Here I have taken 17. This is the first stage of this, or you can say the first state of this example, right? So here you can see that I had two choices in before me, that I can either subtract 4 or I can subtract 3 from it, right? Now after that, whatever case I have chosen, let's say I have chosen to subtract my 3 or I have chosen to subtract 4, either in either case I will be again doing the same operation again. You can see over here in the second state also, either I am selecting to subtract minus 3 or selecting to subtract 4. In both of this condition, after going one step downwards, we are again repeating that same operations. look over here that I'm doing n1 minus 3, n1 minus 4 for again that resultant number. Can you observe something from here? Can you? Okay, let me write it more clearly for you guys. Let's say we are starting with number n, and each and every position we are doing exactly same operation, that is n minus 3 and n minus 4. Again, let's say this resultant number is n1, this resultant number is n2. Again, in the another step, I will be doing n1 minus 3 and n1 minus 4. Okay, so now there is one possibility that starting with n, first of all, I will subtract 3, then I will subtract 4, and over here I am getting a 0. Or else, there can be one more possibility, like I'm starting with n, then I'm subtracting 3, then again in the another step I'm subtracting 3 and I'm getting a 0. Again, similar thing will happen for 4 also. So at the second stage, this will become n2 minus 3 and n2 minus 4. So now look carefully over here that whenever you are repeating same operation at each and every stage of any particular number, what this repetition is indicating you? This repetition is strongly indicating you to something which is involving recursion. You can see over here that same operation is repeating over and over again irrespective of the state of the number. You will be only be stopping when either your number will become less than 0 or your number will be equal to 0. Apart from this, your irrespective of the state of n, you will be doing the same operation again and again. So since you are repeating this operation, this strongly indicates the usage of recursion in this question. So now I guess you are clear that how we end up with the logic of recursion, how we reach at the point where we know that we will definitely going to use recursion for this question. So I hope this is clear. Now let's see that how we can apply recursion over here. So for recursion, there are two things that you have to keep in mind. The first case is base case that you are going to take in your recursion, and second one is your induction case. Now base case, all of you are aware with this thing, that is of base case. Base case is a condition where you are going to stop your recursion, and induction case is that case which will keep on fueling up your recursion. Over here, what is that something which is fueling up your recursion at each and every step? That is subtraction of 3 and 4. At each and every step you are repeating this thing, right? So this will be considering as induction case, and the base case are those conditions which will stop this recursion, correct? So now tell me that when you can stop this recursion, what we have to find. First of all, we have to find that whenever our n is equal to 0, then we don't need to go ahead. We can just return from over here that since we have find this one condition, just return with true, right? I can do this. So one base case can be this, that whenever your n is becoming 0, you don't have to move forward, just return from there only. So this can be one of my stop point, or I can say one of my base case. Now another base case is, let's say there is some number and there is some path through which when we are going through, we will be not getting n as 0. So what will happen in that case? Think about it. What will happen is you will end up with some number which is lesser than 0 in that case. Let's say you have number 2. Okay, at any step, let's say you have n is equal to 2. And if I ask you that now again repeat this thing, so you will again repeat this step, that is n minus 3 and n minus 4. So what you will end up with is 2 minus 3, which will be minus 1, 2 minus 4, that is minus 2. So if you end up with some n through which you are not able to get n as 0, then in that case you will end up with value of n as lesser than 0. So whenever your value of n is lesser than 0, then in that case you have to return false, because in the question you have been asked that you have to return yes only if your n is equal to 0, correct? So here this case is not possible whenever your n is lesser than 0. So in that case you will be returning false. So these are the two base cases. These are the two base cases which will be stopping our recursion. Now what will be our induction case that will be fueling up our recursion? And that is, what is that something that we are repeating at each and every step? Which is that step that we are repeating? And you will tell that this is the step, that is n minus 3, n minus 4, again n minus 3, n minus 4. So this is something that we are repeating. So this will become our induction case. So at each and every point of time, to fuel up the recursion, let's say our recursion function name is recur. Just for the sake of example, I am considering it as recur. So each and every point, we'll be calling this function for both n minus 3 as well as n minus 4. Now, what is the operator that we will use over here? Now, there are two things that you can use. You can think about as and person, or you can think up for or. Now, what you will use out of at any path, if you are traveling through this tree, okay, let's say if you are traveling through this recursion tree, if at any step, if you are ending up with n is equal to 0, then in that case your answer will be true. Correct? Means let's say if every path is giving you false answer, let's say every path is giving you false answer, but a single path has given you true answer, then in that case your whole answer will become true. Now tell me, which which operator among these has this property? Yes, you guessed it right. The operator OR. In operator OR, if a single value is true, then the whole value will become true. So that's why we will be using operator OR over here and not the AND. So this will be the induction case. These are the base case, and in simple way, we will be applying that recursion. So that was it. That was the logic. Now let's have a look at the code. So here is my code. As you can see over here, as per the input format, I have taken first of all n as my input. And after taking that n number, I am passing that n number in one of my recursive function, and the name of the recursive function that I have taken over here is fun. Okay, just for the fun. So if my recursive function is returning true, then you have to answer as yes. And if my recursive function is returning as false, then in that case you have to print the answer as no. Correct? Now let's have a look at my recursive function. It is pretty much simple. As we have discussed in the logic part, I have done exactly the similar thing. First of all, to stop the recursion, I have written the two base cases. That is, if my n is becoming 0, then in that case, I have found such path where my n is becoming 0, so I will be returning true. And if I am not able to find such path, then in that case, I will end up with some n value which is lesser than 0, that is negative. Then in that case, I will be returning false. And this will be my two base cases of this recursion as I have discussed. And after that, for induction function, that will be fueling up my recursion, will be returning n minus 3 or n minus 4 at each and every step. Since at each and every step we can do this two operation, that's why I have written n minus 3 or n minus 4. At each and every step we will be doing it until our n is either becoming 0 or our n is becoming lesser than 0. So I guess this code is clear to you. Now let's try to submit this also. Since I have already submitted, it must be an accepted solution, but still. Okay, yeah. So that was it. That was the logic. And this was the code. I hope you have understood both of those things. And if you have really understood this video, please give big thumbs up to this video, and I will see you in the next one.